Alright, so this is the last part of section 2.1, and we've had these instructions, well, I think we've had these instructions before. If not, I'll refresh your memory. So part A, so each of the questions between 53 and 62 has a part A and a part B. When I go to do 54, part A wants me to find all values of x where the tangent line is horizontal, and to do that, I just have to find the first derivative, set it equal to 0, and solve for x. So for each of the part A's, find all values, find all values of x where the tangent line is horizontal. For each of the part A's, I'm simply going to find the derivative, set it equal to 0, and solve for x. So when I go to do 54 part A, f of x is equal to 2x squared minus 5x plus 7. F prime of x, I'm going to multiply the exponent 2 by the coefficient 2 and get 4. Lower the exponent from 2 to 1, so I get 4x to the first power. The second term is a x to the first power term, and the derivative of any x to the first power term is just its coefficient, so that derivative will be 5, or minus 5. And the 7 doesn't have an x, it's a constant. The derivative of any constant is 0. So now I have the derivative. To find the values of x where I have a horizontal tangent, I simply set the derivative equal to 0. This is going to take 2 steps to get my value for x. I'm going to add 5 to both sides, which will give me 4x equals to 5, and then I'll divide both sides by 4. And the answer to 54a, the values of x where the tangent line is horizontal, there's just going to be one value here, x equal 5/4. That's all I need to do for part A. And now as I move down to part B, I want to find an equation for a line. And to find an equation for a line, you need a point and a slope. In each of the problems that we're doing between 53 and 62, we're finding horizontal lines. Horizontal lines, their slope is 0. And I can tell their slope is 0 because the slope of any tangent line is what I set the derivative equal to. So when I go to do part 54b, I'm shooting to find an equation for a tangent line. The slope is going to be 0. And, better yet, I have the x-coordinate of the point that I need to find the tangent line on for. So when I move down to part B of 54, we just write down the original equation again. So for 54 part B, the original function was f of x equals 2x squared minus 5x plus 7. I know that the slope of my line, because I set the derivative equal to 0, and the number that I set the derivative equal to is the slope of the tangent line for that value of x. So the slope is going to be 0, and my point has an x-coordinate of 5/4. That's what the algebra gave me when I did 54a. To finish up 54b, I need to get the y-coordinate of the point, and I'm going to get the y-coordinate of the point by taking the x-coordinate and plug it in not to the derivative, but plug it into the original function. It's probably a fraction. I don't really care to do this work by hand, so I'm going to pull out my calculator and have my calculator do that work for me. So real quickly, I just break out my calculator. I'm going to go 2 parentheses 5 divided by 4 squared minus 5 parentheses 5 divided by 4 plus 7. Probably gives me a decimal. I hit math, enter, and enter to get my fraction. The y-coordinate of the point that I'm searching for is 31/8. If I was clever, I could write down my answer to part B without really doing any more work, because anytime the slope of a line is 0, the equation of the line that passes through the point with the slope is going to be y equal the y coordinate of the point. I'll go ahead and do the algebra so you can see that this shortcut works. So to find an equation of a line, if you have a point and a slope, you can use the y minus y1 equals m times x minus x1 formula. And when I use that, what I'm going to do is take the value, the y coordinate of the point, plug it in for y1. So in for y1, I'm going to plug 31 over 8. I'm going to take the slope of the line and plug that number in for m. And I'm going to take the x coordinate of the point and plug that in for x1. When I do that, the left side temporarily is going to say y minus 31 over 8. But the right side, 0 times any quantity is equal to 0. So 0 times the quantity x minus 5/4 is equal to 0. If I want to get this solved for y, I would just add 31 over 8 to both sides. And when I do that, on the left side, the 31 over 8's cancel. I'm left with the y. And on the right side, anything plus 0 is itself. So that's the answer to 54b. That's the equation of my tangent line. It turns out that these are relatively easy to check. To check these, all I would have to do is graph the original equation in y1, graph the answer to 54b in part 2, and this tangent line has to go through a hump or a valley. Because this is a parabola, it's going to go through the vertex of the parabola. So any tangent, the only tangent line that is horizontal for a parabola is the one that goes through the vertex. So quite simply, to check this, I could clear out any values I have in my y's and graph 2x squared minus 5x plus 7 in my y1, and in my y2 I can make 31 over 8. I can go zoom down to number 6 and say standard. First it's going to graph the parabola, then it's going to graph the tangent line, and for the tangent line to be correct for a parabola, it has to go through the vertex of my parabola. So I simply, there's the parabola, here comes my tangent line. If it didn't go directly through the vertex, I know I have a mistake. Because it went directly through the vertex, I know my answer is correct. That's all there is to do for 54, parts A and B. 56 is a little, I don't know if it's trickier, but maybe it is. So I'll move down to 56, and we'll just kind of go through all these, and you should, again, make your stab at doing problem 53, kind of using my 54 as a template. So for 56, to do part A, to find the values of x where I have a horizontal tangent line, I need a derivative. And I certainly can use the product rule to find the derivative of f. If I didn't want to use the product rule to find the derivative of f, I can rewrite f by foiling it out, and that's what I'm going to do. I'm going to rewrite f by foiling it out to make the derivative easier to do. So I'm going to, before taking the derivative, which is what I need to do to find the values of x where I have a horizontal tangent, I'm going to FOIL this out to take the derivative. The first are going to be 2x times x, which are 2x squared. The outers are going to be 2x times 1, which is positive 2x. The inners are minus 5 times x, which is minus 5x. And the lasts are minus 5 times 1, which is minus 5. So this whole parabola comes out to f of x equals to 2x squared minus 3x minus 5. I haven't taken a derivative yet. If I set the function itself equal to 0, I'd find x-intercepts, but that's not going to be where the tangent line is horizontal. That won't have anything to do with the vertex of this parabola. Again, this is an x squared equation, so it's a parabola. To finish up part A, I take the derivative. For the 2x squared, I multiply the 2 by the 2 and get a 4. Lower the exponent to x to the first. So the first part of my derivative is 4x. And then the middle term is an x to the first power term. The derivative of any x to the first power term is just its coefficient. So the derivative of minus 3x is minus 3. The last term, minus 5, has a derivative of 0. So that's the derivative. To find the values of x where I have a horizontal tangent, I need to take the derivative and set it equal to 0. This is going to involve taking 4x minus 3 and setting it equal to 0. to do this, I add 3 to both sides. That gives me 4x equal to 3. And then I divide by 4, and I get the only one value of x where I have a horizontal tangent is x equal to 3/4. So I'm done with part A. Part B wants me to find the equation of the tangent line. And in order to find the equation of any line, I need the slope and a point. The slope, because I'm finding the equation of a horizontal line, is going to be 0. Again, if you take the derivative and set it equal to a number, the value of x that corresponds to that number is going to be the x coordinate of the point, and what you set it equal to is the slope. So when I go down to 56b, when I try to find an equation of a tangent line, my slope is 0 because horizontal lines have a slope of 0. And my point, the x coordinate is x equal to 3/4. I need to get the y coordinate, and to get the y coordinate of any point, I need to take the corresponding x value and plug it into any version of the function. So I can plug 3/4 in for that version of the function, or I can plug it into this version of the function, because these two are equal to give the same y value. It doesn't matter which version of the function I'm working with. So if I use this version, I'd go 2 times 3/4 minus 5 times 3/4 plus 1. And if I did that, get out to my main screen, second quit, I'd go parentheses 2 parentheses 3 divided by 4 minus 5 parentheses 3 divided by 4 plus 1, close my parentheses, and then math, enter, enter. I get negative 49/8 for the y coordinate. Just to show you that I could have used the value of the form of x that I went to take the derivative from. If I plug 3/4 in for that and did 2 times 3/4 squared minus 3 times 3/4 minus 5, I have to get this same answer, the negative 49/8. So let me try that real quick. Go 2 parentheses 3 divided by 4 squared minus 3 parentheses 3 divided by 4 minus 5. And math, enter, enter. I still get the same minus 49/8. So if you modify the function before taking its derivative, to find a y coordinate of the point, you could use the original function, or you can use the modified version. And now I should be able to get an answer without doing the long way. But the long way to get the answer would be to use the information I have along with the formula y minus y1 equals m times x minus x1. Into this formula, in for the y1, I'd plug negative 49/8. Since I have a double negative, I need a parenthesis to separate that double negative. In for the m, I'd plug for 0. And in for x1, I'd plug 3/4. On the left side, the double negative turns to be positive, so you get y plus 49/8. And on the right side, 0 times any quantity gives me 0. The right side comes out to be 0. And then I minus 49/8 from both sides. And that's going to lead me to my answer to part 56b. So the answer to 56b is going to be y equals negative 49/8. Again, I could take the original function, put it in y1 and graph it, graph my answer to 56b, and because the original function graph is going to be a parabola, my answer to 56b, the horizontal tangent line is going to go right through the vertex. So let me just do that to show you real quickly. That if I graph the original equation, or the multiplied version of the original equation, 2x minus 5 times x plus 1, and if I graph the minus 49/8 as a separate function, the initial graph is going to be a parabola, and my answer should go directly through the vertex. If my answer for a horizontal tangent line when the original graph of the function is a parabola doesn't go through the vertex, then you made a mistake somewhere in your algebra. Alright, so go ahead and give 55 a go, and then we'll move on to 57 and 58, which look a little messier, but maybe they are a little messier, maybe they're not. I sense that 57 and 58, we're going to get two tangent lines that we're going to have to find. So when I go to do part 58a, to find the values of x where we have a horizontal tangent, I need to find the derivative of the function given in 58 and set it equal to 0. To find the derivative, it's already multiplied out, so I'll just use the general power rule essentially. I'm going to multiply this exponent of the x 1/3 x to the 1/3. I'm going to multiply that 3 by the coefficient of 1/3. I'm going to lower the exponent by 1. For the second term, I'm going to multiply the exponent of 2 by 3, lower the exponent by 1. The last term is a first power term. The derivative of any first power term is just its coefficient. So when I go to simplify this, 3 times 1/3 is 1. Those are reciprocals of each other, so they multiply out to be 1. And when I go to write this down, I don't need to write the 1. I'm just going to write the x squared. The middle term, 3 times x to the first, is a 6x. The last term is minus 7. So now I'm going to take the derivative and set it equal to 0. I'm going to factor this, which factors into x plus 7 times x minus 1. I got to set the equal to 0. And then I'm going to split each factor up and set each factor separately equal to 0. For the x plus 7, I'm going to minus 7 from both sides and get x equal to minus 7. For the x minus 1, I'm going to add 1 to both sides and get x equal to 1. So the answer to 58a, there are two values of x where I'm going to have a tangent line that's horizontal, which means the value might have both, the graph probably has a hump and a dip, as much as my best guess. That's 58a. Alright, so now we're on to 58b. And in 58b, because I got two values of x in part A of 58, I need to get two different tangent lines. Each of the tangent lines is going to have a slope of 0. And the x values of my answer to part A are going to be the answers, or the x coordinates of the points that I need in 58b. So I took the values of x that I came out with 58a and used those as my x coordinates of my points. Now I need to get y coordinates, and the y coordinate of this is kind of messy. To do the y coordinate of this, I go 1/3 times negative 7 cubed plus 3 times negative 7 squared minus 7 times negative 7. That's simply going to this function and changing each of the three x's to a negative 7. And now I do that on my calculator because I can't want to do that by hand. So that's going to be 1 divided by 3, and then parentheses negative 7 up arrow 3 plus 3 parentheses negative 7 squared minus 7 parentheses negative 7. And I get 81.666. So math, enter, enter. 245 over 3 is that y coordinate. To get the y coordinate of this point, I'm going to go 1/3 times 1 cubed plus 3 times 1 squared minus 7 times 1. Let me go ahead and do that real quickly. So 1 divided by 3 times 1 in parentheses cubed plus 3 times 1 squared minus 7 parentheses 1, and I get negative 11/3. I'm going to speed through these doing my cheating method. Anytime the equation of a line has a slope of 0, anytime a line has a slope of 0, the equation of the line has an equation of x equal the x coordinate. The equation of the line is y equal the y coordinate of the point that it passes through. Sorry, I'm trying to do this without doing the proper algebra, and I started messing up. So that's why it might have been safer to do y minus y1 equals m times x minus x1. But I'm gambling that's the right answer. And it's not too much of a gamble because I can easily check to see if my answer is correct. And I check to see if my answer is correct by, in y1, putting my initial function, so I'll go ahead and do that real quickly here. So in my y1, I do 1 divided by 3 x up arrow cubed plus 3x squared minus 7x. And I'm going to try to show you each one of these separately. The first one I want to show you is the 245, y equals 245 over 3. And that was like 80 something. If I just hit zoom standard on my calculator, I'm not going to see that tangent line, because in a zoom standard, the y's only go between -10 and 10, and that's around 80 something. To see this properly, I have to hit my window, and I have to make the y max something bigger than that, which is like 80. So if I make my y max like 100 and then graph it, I'm going to see the hump that my tangent line's going through. It should go directly through that top hump, which it did perfectly. I guess I won't even need to change the window to see that line, that tangent line right there. It has to go right through that valley right there. So let me just put this in a y3, go down to, well, actually it's actually a y4. Go down to this and go -11 divided by 3 and graph it. And now it goes right through the valley. So that's exactly what you expect to happen when you're finding the equations of horizontal tangents. Generally, the graph is going to have a peak or a valley, and the horizontal tangent line goes right through the peak or right through the valley. If it has both in a peak and a valley, you get two horizontal tangent lines like I did in 58b. So there's two more problems left. One of them is kind of messy and one of them isn't so bad. I'm going to do them, I think, in reverse order, just because I'll do the easier one first and save the hardest one for last. So go ahead and give 57 a go. So we just have two problems left. Problems 59 and 60 are way worse than 61 and 62. So let me do 62 first, and you can do 61. If you skip problem 59, it won't hurt my feelings. I'll do problem 60. Turns out you need the quadratic formula while you're doing it. And the y-coordinate of the point is going to be unpleasant. I'm going to make it into a decimal. So let me give these a go. So first thing I need to do with part A is find the values of x where the tangent line is horizontal. Of course, that involves finding the derivative and setting it equal to 0. So I'm going to find the derivative. For 2x cubed, I'm going to take the exponent 3, multiply it by the coefficient 2, lower the exponent by 1. So the derivative of 2x cubed is 6x squared. And for the minus 4x squared, I'm going to take the exponent 2, multiply it by the minus 4, or x squared, and lower the exponent down to 1, and I'm going to get a derivative of minus 8x. So the derivative of 2x cubed is 6x squared. The derivative of minus 4x squared is minus 8x. So the derivative of the function in problem 62 is 6x squared minus 8x. So to find the values of x where the tangent line is horizontal, for 62a, we're going to take the derivative and set it equal to 0. I'm going to factor out the common factor of 2x, and that's going to leave me with a 3x minus 4. When you have something that has a square that's set equal to 0, the best strategy for finding the values of x that solve that equation is to factor. If it doesn't factor, you might have to use some other strategy like the quadratic formula. So now I have it factored. I'm going to split the factors up and set each one equal to 0. For the 2x equal to 0, I'm going to divide both sides by 2, and I'm going to get x equal to 0. For the 3x minus 4 equal to 0, I'm going to add 4 to both sides and get 3x equal to 4, and then divide by 3 and get x equal to 4/3. So my answer to 62a, the values of x where there are horizontal tangents are x equals 0 and x equal 4/3. to do 62b to find the equation of the tangent lines, because there's two values of x, I need two lines. And to find an equation for any line, you need a point and a slope. The x-coordinate of the first point is going to be 0. The x-coordinate of the second point is going to be 4/3. Because we set the derivative equal to 0, that's the slope of the tangent line, and the slope of my tangent lines in each of these is going to be 0. For each of these points, I need to get a y-coordinate. To get a y-coordinate, I take the value of x and plug it into the original function. So for the first x equal to 0, I need to go 2 times 0 cubed minus 4 times 0 squared to get this y-coordinate. And that's 0, but I'll do it on my calculator really quickly. I'll go 2 times 0 up arrow 3 minus 4 times parentheses 0 squared gives me 0. To get this y-coordinate, I have to go 2 times 4 divided by 3 cubed minus 4 times 4 divided by 3 squared. And it's going to turn into a fraction. I'm going to have to math enter to make that into, I was going to make a decimal that I'll make into a fraction by math entering. So this y value, I go 2 parentheses 4 divided by 3 up arrow 3 minus 4 parentheses 4 divided by 3 up arrow 2 decimal math enter. This y coordinate is negative 64 over 27. Because the slope of the tangent line is 0, the equations for my answer are always going to be just y equal the y-coordinate of the given point. Rather than going y minus y1 equals m times x minus x1, I'm going to shortcut, like I think I've been doing. This is for these two problems. I'm redoing these after like 3 months. But anyways, I believe that's what I was doing. So this equation is going to be y equal to 0. This equation is going to be y equals to negative 64 over 27. I need to check these by graphing. So I'm going to graph the initial equation. And I'm going to do it on a standard window. So I'm going to go y equals clear 2x up arrow 3 minus 4x squared zoom standard. Might not be the best window, but I think it's going to be sufficient. And now I'm going to graph y equal to 0 and y equal to negative 64 over 27. The y equal to 0 is going to be the x-axis. I'm not going to see it, but it's going to touch that hump perfectly. The y equals negative 64 over 27 is going to go through that little hump right there. So check now by doing y equal to 0 and y equal to negative 64 over 27. First line, it's actually drawing on the x-axis. I don't see it. The second line goes perfectly through that hump like I needed it to do. So I'm pretty sure these answers are right, and I'll move on. You should do the same thing for 61. If you don't watch my video for 60 and you skip 59, that's probably a better idea. But if you're just want to see some grunge, I'll do it for you now. It's a really unpleasant problem that I got wrong like 4 times when I was doing it. It was horrible. So, for part A, to find the values of x where the tangent line is horizontal, we need to take the derivative and set it equal to 0. So y prime, the derivative of x cubed, I take the 3, multiply it by the 1 that's assumed in front of the x, and I get 3 times 1 is 3, lower the exponent by 1 and get 3x squared. And then second piece, 2 times minus 4 is minus 8, lower the exponent to 1 and get x to the first. Third piece, I go 1 times minus 7 because it has an exponent of 1 that's assumed. 1 times minus 7 is 7, lower the exponent to 0. Fourth piece is a constant, it has a derivative of 0. So writing this a little bit cleaner, I'm going to get 3x squared minus 8x to the first, and I'm not going to write the exponent of 1. And this really is minus 7 times 1 because x to the 0 is 1. So that's just minus 7. So set this equal to 0. 3x squared minus 8x minus 7 equals to 0. This is bad because it doesn't factor, so I have to use a quadratic formula that says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a to solve this, which makes this whole problem horrible. So in this particular problem, the a is the number in front of the x squared, the b is the number in front of the x to the first problem, and the c is the constant. I'll take those numbers and plug them in. I'm going to get x equals negative 8 plus or minus the square root of negative 8 squared minus 4 times 3 times negative 7 over 2 times 3. Because this isn't a problem that I want to spend a lot of time on, I'm going to do this on my calculator that does square roots better than my big calculator. So I'm pulling out my cheap old calculator, and if you had me for intermediate, you saw me use this a lot. I'm going to go fraction, negative parentheses, negative 8. Can't do plus or minus, but I'll do plus. And then square root, parentheses, negative 8 squared minus 4 parentheses 3 parentheses negative 7 all over 2 parentheses 3. And this will give me one of the two answers. Well, if I actually did that, hit enter. And one of the two answers is 4 plus the square root of 37 over 3. Then the second one, I need to go back and change the plus sign in front of the square root to a minus sign. So I get right next to it, I delete, make it a minus sign, and that answer is going to be 4 minus the square root of 37 over 3. So the answers to part 60A, again, you're not responsible for 59. If you're watching this, I thank you for watching my struggles, but you don't have to. So that's the beginning of the grunge. That's the answer to 60A. Now I'm going to move into 60B. And for 60B, we need points and slopes. Well, slopes are good because we set a derivative equal to 0, so the slope is 0. So for 60B, I'm going to have 2 points. They each have a slope of 0. The first point has an x-coordinate of 4 plus the square root of 37 over 3. The second point has an x-coordinate of 4 minus the square root of 37 over 3. There is nothing pleasant about finding the y-coordinates, and if I wanted to get a y-coordinate that was something that wasn't a decimal, it would take me about 20 minutes and I'd probably make 3 mistakes and it'd be hard to follow anyways. So what I'm going to do is I'm going to let my calculator find the y values, and when the x values are this crazy, I get the y values by taking the original function, plugging it into my y equals, and then using the value feature. So to get these y values to finish up 60b, I'm going to take the function before I took its derivative, x up arrow 3 minus 4x up arrow 2 minus 7x plus 8. Graph it. The window might not be that great. In fact, I'm going to maybe make this window higher and lower to see the peaks. Make the window maybe negative 30 to 30 so I can see a better graph. There's the top, there's the bottom. That's a pretty graph. Now I'm going to get that and that y value by cheating in some sense, but I'm going to cheat because it's too messy to do by hand. I'm going to take this value and plug it in for x by going second calc value, and I'm going to go 4 plus second square root 37 parentheses parentheses divided by 3, and it shoots right down there at negative 22 point, I'll say 75. So the y-coordinate of this point is negative 22.75. And then I'll do the same thing to get this y. I'm going to do second calc value, parentheses 4 minus second square root of 37, parentheses, divided by 3. And I get 10 point, I'm going to round that to 2 decimals and get 0.60. So those are the y-coordinates, and for each of these problems, when you're finding a horizontal tangent, you can just find the equation of the line quickly by taking y and setting it equal to the y-coordinate of the point that has the 0 slope. So that's going to be my answer to 60B without a lot of explanation, because I'm not assuming too many people are watching this. I'm going to graph both of these to make sure they go through the humps. So I need to check my answer by graphing y equals negative 22.75 and y equals 10.60. When I graph these, I have to go right through the hump. That went perfectly through the bottom hump. That went perfectly through the top hump. So I know my answers at least are correct in terms of as correct as they can be for decimal approximations of the correct answer. So I pulled out a lot of technology to do this problem. And again, you're not responsible for problem 59 to do some of the stuff that I did, by hand. It's just a nuisance. And there's enough grunge in this course. I don't need to pile it on any more than it's going to be piled on. So we'll call that the end of section 2.1. And again, if you skip 59 and 60, it's completely okay. Just as long as you know how to use the general power rule, and if you can find the equation of tangent lines and slopes of tangent lines, that's where you need to be after you finish the section.